Hello everyone, welcome to Embedded Laboratory. In today's video, I will show you how to create a weather station web server using ESP32, which also has OTA capabilities. The program is written with the ESP-IDF framework, and after uploading the firmware into the ESP32, it acts as an access point where several other devices can connect. In the Wi-Fi application.h file, we have specified the SSID, password and other important information related to the ESP32 access point mode. I will use my laptop to connect with the ESP32, and after a successful connection, I will open the IP address 192.168.0.1 in a web browser. This will load the index.html web page stored inside the ESP32. As you can see here, a DHT11 sensor is connected with ESP32 to get the temperature and humidity sensor values, and this web page is continuously requesting the temperature and humidity data from the ESP32 every 5 seconds, and whenever the ESP32 receives this HTTP GET request, it will call the corresponding handler function associated with this GET request to send the temperature and humidity sensor values to the web page. Now I will demonstrate the OTA capabilities of this project. As you can see, whenever I hover over the select file and update firmware buttons, we can see that the color changes to red color, and to be honest, I didn't like this red color. So as a next step, I will change this red color to a dark green color, as shown here in the app.css file, and once this is done I will recompile the project. So now as you can see, the project is built successfully, and I will use this select file button to load this file, and then click on the update firmware button to upload this new program into the ESP32. As you can see here, I am not using the USB to serial interface for updating the program. In fact, this updating is done directly from the web browser. Once the program is updated completely, ESP32 will be restarted, and the web page will also be refreshed, or in some case you might have to reconnect with the ESP32 access point again. Now here you can see, whenever I hover over the select and update firmware buttons, the color is not red, but it is dark green, which means that the program is uploaded successfully and is working fine. This is a little complex topic, and explaining each and every part of this project will take a lot of time, and it will make this video very long and boring. Instead of that, I will try to explain the most important things in code flow. But before proceeding further, I would like to thank the sponsor of this video, PCBWay. With more than a decade in the field of PCB prototype and fabrication, they are committed to meeting the needs of their customers from different industries in terms of the quality, delivery, cost-effectiveness, and any other demanding requests. They are one of the most experienced PCB manufacturers in the world. I hope my video's viewers will visit their website at least once to show their offerings. Before proceeding further, let's discuss the prerequisites for this project. You should have an ESP32 development board, and since we are using the ESP-IDF framework for the development of this project, make sure that the ESP-IDF framework is installed on your computer. And then we need a DHT11 sensor, which is used to measure temperature and humidity values. You can use any other temperature sensor, such as the DHT22BME sensors, but then you have to adjust the sensor-related source code accordingly, because this project is specifically made for DHT11 only. We should also understand that what we have to do in the source code, and this is explained with the help of a use case diagram, which is used to illustrate all the things we are doing in software at a very high level. Here the first step is to measure the temperature and humidity values from the DHT11 sensor, and then store them in a file-specific global variable. Then the next step is to configure the ESP32 in access point mode, so that external devices, also known as station, can connect with it. This enables the user to access the information, example sensor data, device information, connection status, and many other things. Then we should also create a HTTP server, and this HTTP server should support displaying of the web pages, such as HTML, CSS and JavaScript. Then this HTTP server should be able to display the temperature and humidity sensor readings on the web pages, and it should also be able to update the firmware directly from the web page, which is also known as over-the-air, or OTA functionality. The project is divided into several modules, and each module handles the individual task. The first module is the DHT11 sensor module, and this module is used to get the temperature and humidity values from DHT11 sensor. I am not going to explain each and every line of the source code. In fact, you can download the source code from the links given in the description of this video, and then you will find that all the important logics and actions are commented very properly and in details in the source code. But in case still you have some doubt related to specific piece of code or anything else, then you can ask the questions in the comment section or by sending an email to me. The next module is the Wi-Fi application module. This module is triggered from the main module, and the purpose of this module is to configure the Wi-Fi settings, such as SSID, password, IP address, netmask, gateway, number of allowed connections and many other things. This all is done inside a task which is used to initialize all the default configurations and then start the Wi-Fi using the function ESP-Wi-Fi start. This module will trigger the HTTP server module, which is one of the most important module for this project. The next software module is the HTTP server module, which is the key component of this wireless LAN application, and it also supports the web page functionality. As you can see here, there are a number of files such as HTML file, JavaScript file, and CSS file. These files are embedded inside our ESP32 firmware. This module configures the HTTP server and also creates an HTTP monitoring task. And when the HTTP server is started, we register some URI as shown here. The URI has a callback function that handles all the requests from and to the web pages. For example, the mentioned function here is a callback function for sensor JSON URI, and on the web page side, we have configured to send the GET request every 5 seconds, which means that the sensor value handler function will trigger after every 5 seconds, and it will send the message back to the web page with temperature and humidity values, which in turn will be displayed on the web page. Similarly, we have a registered URI for the OTA updates, so whenever the OTA updates are triggered from the web page side, the corresponding handler or callback function will be called, and this will receive the binary content from the web page and store this in another partition. As I mentioned previously also that the code is commented very properly, and just to highlight this, OTA update section is commented with great amount of details. So, just download the code and try to read along. I think I have covered the most important points from the source code, and as I mentioned previously, it is not possible for me to explain each line of the code in this short video tutorial because it will make things very boring. But in case somebody is really interested in watching everything step by step, then I would recommend you guys a course on Udemy, for which I have given the links in the description of this video, so you can check out this course on Udemy. I think that's all from this video. If you guys have any doubt in understanding some piece of code, then let me know in the comments section, and I will try to reply you guys as soon as possible. And if you like this video, press the like button, share this video with your friends, and don't forget to subscribe this channel. Thank you.